This course is structural engineering for civil design 2. So really what I expected out of this course was to get a more in-depth industry knowledge of what exactly an engineer does and how we apply all the knowledge that we learned over the last, 4 or 5 years taking the courses here. So really my big hopes was to kind of take that knowledge and learn to optimize it, learn to be efficient with it, and learn to help people actually solve problems with it.
Hi, my name is Okian Samura. I'm a senior as well, and I'm graduating soon. I'm actually going to construction management, so structural is not the route that I'll be going into. What I hope to get from this class was, just more of what Chris said. Just getting a more in-depth idea of how structures are actually built and designed, and I hope that that would help me be a better construction manager somehow. All right. Next up,
I'm Erin Foodie, and I'm a senior civil engineering major. I'm also president of NJIT Green, and tomorrow is our Earth Day celebration, which I have worked for many weeks to prepare, and I'm super excited to be able to run that event. I'll be going into site civil, not so much structural, but I work at NV5 once I graduate, and I'm super excited.
Hey, I'm Ofek Nahar, also senior graduating now, and pretty much got what we expected out of this class in my opinion. A lot of knowledge about how practicing as a structural engineer would be, and in the future I'm not sure which route I'll go yet. I still have to weigh my options and figure it out. It's either going into the structural route / civil engineering route, or continue with my current job and start my own business through that. But yeah.
I'm Caden Rolando, a senior, and I'm interested in maybe doing site civil or structural. I was captain of the steel bridge team, so I kind of took this class hoping to learn more about structures and how things work together and hold stuff up. And I've had fun designing this building. It's cool to see how buildings actually work, because I never really had an idea how they went together. So it's interesting working in this class.
Yeah, there's been a big avenue of creativity here with coming up with new unique ideas, even if they're not the industry standard, but seeing how well they work and how well they compare, and then making that more practical.
Ofek and I we got a chance not only to work on the 40-story building, but actually to design a solar panel tree. I've seen some imitations of it, but none that, like the one that we're working on with some mechanical engineers, ours will actually be able to move throughout the seasons. There's a crank for it to turn, for the angle of the sun is different in the summer versus the winter. So we're trying to optimize, the solar capacity of these panels so that, they'll get the maximum amount of power for people to just charge their devices.
And then again, incorporating creativity as we've been.
This is the drone chat finished project, which is opened May last year. There's a Pier 7, PT7.
How public policy decisions are made, traveling around the world, go to Turkestan, Kazakhstan.
And I noticed an interesting connection between that and the conversation of divergence versus convergence. Would you say that at our stage of life, it's more about exploring new options and finding where we fit in, exploring all the divergence?
Obviously, there's some flaws in this design. Needs a little bit more structure stability, if you will. So I worked with a couple of mechanical engineers on this project, and OFAC helped as well. We drew some inspiration from these two designs. This first one is from, this one's in California, and this one actually moves. You can see at the top, the solar panels can pivot. If you can see, it's this tree, but much larger. It stands at over 14 feet tall, and we were looking at the placement of the sun in the sky. The sun is always to the south. Our model, and then mechanical engineers also made one, which I'll play.
Oh.
Their model isn't as flush with the pipe, but ours shows it completed. If you know the scene, we chose a site in New York City, block 1017, lots 1, 2, 3, and 4.
There's actually not a lot of deflection there. So we're going to talk about the strength in just 1 second. So try and use as many standard shapes as possible.
So for our first test, we tried doing just the concrete part wall to see how much reinforcement we needed to add.
24th, 25th floor. And then there's also
We have UTA urban landfill substratum, and we also had a maximum differential sediment of 0.34 inches. And finally is a material takeoff, which we have looking down.
Okay. Good morning, everybody. We are Metal International. We are made up of myself, Sebastian Ricardo, Christian Erickson, Robert Tadeo, Luca Raza, and Kyle Espiza. And this is our 40-story commercial building presentation. And we have a service elevator for any heavy-duty stuff. We have an electric room. We have a telecommunication room. And yeah, that's what generally makes up the core.
It was 1.2 times the dead load, 1.6 times the live load as a combination we used for these calculations. Then for the beam deflections, it obviously varied per beam depending on the size that we were.
Lateral load, we have a concrete wall which changes sizes, and it's going from 6,000 psi to 9,000 psi concrete strength. And then we also have an outrigger system. There's 2 outriggers on each side.
Specifying current buildings and their depth to bedrock. So our site is at 40.75 degrees due north, and if you see here, they're roughly around 10 feet.
A total of 2,942.30 tons of steel and 21,844.79 cubic yards of concrete, and that is also separated into the lightweight 6,000.
We are structures which are great. Swag. My name is Molly Saylor.
John Morella.
I'm Jazz. We're excited to present you our 40-story building today.
Distributions of 15 feet wide on both sides. Then we have a concrete shear wall at the center, and the girders and columns are connected into
seismic and wind. So first is our concrete core.
The New York City skyline, and also pay homage to the modern and contemporary feel of
Beams also extend from the concrete core tower, and towards the edges where you have shorter spans, you're using smaller sections, and for the girder beams, you're using larger sections.
Simulations. On the left, we have the elevation view 1, elevation view 2, and this is a building fully designed, finished. On the bottom left of view 2, you can see the purple.
And once we running the third software, we got the settlement at 0.27 inches in the middle. The plot summary that we got from our design. The table on the bottom is for the process.
So our mission statement is to provide creative solutions to creative ideas, and the purpose for our tool.
As for firing, so as I said, we're using reactor.
We decided to install outriggers around the center of the building. So we installed outriggers from stories 18 through 20.
And this just shows the reaction forces that is embedded into the map of the foundation. Next. So it shows here the different objects, sections, the materials, and quantities that is needed for the project. So
okay, now I forgot my yes. Alright. Now two things is general engineering loop. Okay. Ready? Go on then. 1, 2, 3. Then next one is whatever you just silly for silly. Alright. 1, 2, 3. Go. Okay. Alright.